Alright, so in the last video we were introduced to the idea of trigonometry, why we might need to use trigonometry, and we were also introduced to the three trig ratios, sine, cos, and tan, and we looked at very briefly when we should use which of the ratios. So in this video we're going to be actually learning how to use those three trig ratios by looking at 5 examples. So before we get into the examples, we need to actually pick apart the three trig ratios a bit more. Last time we saw that we had saw, car, and tour. So these were the three mnemonics that we had a look at. This one was for sine, so the O is opposite, H is hypotenuse, and the A is adjacent. So if you haven't seen the previous video, actually go back and watch that, and this video will make a lot more sense. So when we have sine, we didn't really look at what this meant in too much detail. We just saw when we have to use which ratio. But what this is telling us is that if we have sine, so if we have sine theta specifically, this is equal to opposite over hypotenuse. So this is what the mnemonic really stands for. So in the last video I didn't touch this actual mathematical equation part of this mnemonic. I just showed you guys when we might need to use which ratio. But if we have some missing angle, so we saw, not missing angle, sorry, some given angle. So in the last video we saw that we denote the given angle by theta. So the sine of that angle that we're given will be equal to the opposite side over the hypotenuse. Now if we need to find either the adjacent side or the hypotenuse and we're given one of those two sides, we need to use cos. Now what this mnemonic means, or this abbreviation, is that if we have cos theta, it will equal the adjacent side over the hypotenuse. And for the tour, if we have tan theta, it will equal to the opposite side over the adjacent side. So I'll try to write a bit neater. It's been pretty messy. Okay, so this might still seem pretty abstract, but once we have a look at some examples, it will become much more concrete. So the first example we'll look at, okay, is this right angle triangle here. I have my right angle here, x here, 42 here, 42 degrees, and then I have 8 here. Okay, so the first thing to do is to identify what sides we've been given and what side we need to find in relation to this angle here. So this 8 here that we've been given, okay, is actually opposite this right angle. So this is the hypotenuse. I'll just write H. Now this side here, x, the missing side, the one that we need to find, is actually the adjacent side since it's next to this angle here. So the ratio that I need to use, so the next thing that I need to do is I need to think about the ratio to use. So this is the adjacent side for A. Now I have my hypotenuse, I have an adjacent side. Which one should I use? I should use this cos ratio here. And when you first, this is why this mnemonic is so helpful. So when you first learn trig, you might not remember which ratio corresponds to what. So it's really useful to learn this. So you might find yourself writing out that this is the adjacent side, this is the hypotenuse side, but you might not remember which trig ratio to use, in which case this mnemonic will be very helpful. So I can just go saw, car, tour, car, adjacent, and hypotenuse, and I'll know that I have to use the cos ratio. So cos is equal to adjacent over hypotenuse. So the way that I would actually use this is that I would have cos, and I said that this theta is the angle that we're given. So it would be cos 42, because that's the angle that we're given, is equal to adjacent, so the adjacent side, in this case we don't know what it is, it's x, over hypotenuse. So this one is just going to be 8. Now comes a bit of algebra where I have to rearrange this to make x a subject. So I'll have x is actually equal to 8 times cos 42, which I can just write like this. So I just multiply the 8 across. Now what I need to do is I need to actually put this into my calculator, and I'll get the answer for x. So the way that I do that is I type in 8, then cos. So on the Casio FX calculators, the cos is going to be in the third row of buttons, and it's the second one from the right. So then just press cos, then type in 42, and then you actually need to close the brackets. On the Casio calculators, it gives you an open bracket, but if you don't close it, sometimes you'll get an error. So it's good practice to just close the bracket. And this gives me 5.945. Okay, so if I wanted to write it to 2 decimal places, it would be 5.95, but I'll just leave it as 3 decimal places. Now, if they give you a unit, you should write in the unit, but in this case, we don't have a unit, so we'll just leave it as it is. Okay. So hopefully this one makes some sense. If it doesn't, that's okay. The more examples we do, the clearer it will become. So now let's have a look at the next one. Now we can't see our little mnemonic. We'll try to do it without the mnemonic. The next one that we'll look at is this right angle. Oh, it's not a good diagram. Let me just rub that out. Try it again. Oh, that's marginally better. Let me just rub this out. Clear up a bit. Okay, there we go. Right angle there. Okay, so this time I have x here. I have 42 there. Again, 42 degrees. I have 20 here. So they can give you the triangles in any orientation. It doesn't always have to be the orientation that we were given in the previous example. But in this example, like I can have it sort of rotated around, but it doesn't change which sides are what. So again, I have my angle here. This side that I'm interested in is opposite, so opposite the angle, so the x is opposite the angle, so it will be the opposite side. And this 20 is opposite the right angle, so it will be the hypotenuse. So I have the opposite and the hypotenuse that I'm interested in. Which ratio should I use? So so ka tua, so so is opposite and hypotenuse, so I need to use the sine ratio. So I have sine theta is equal to opposite over hypotenuse. Okay, now again, my theta is going to be the angle that I'm given, so it'll be 42. So sine 42 is going to equal to opposite, so the missing angle that, missing side that I have, x over the other side that I'm given, 20. Now, very similar to the previous question, what I need to do is I just need to multiply this across, and I'll get my x as 20 sine 42 degrees. I can put a degree there if I want. And again, I just need to type this into my calculator. If I do 20 sine 42, so 42, close the bracket, this will give me x as 13, this time I'll write it to 2 decimal places, 13.38. Okay, so very similar to the question that we've done before. Now, once you guys do some practice with this, it will become very easy. It's basically the same thing every single time. All right. So in this case, we just had to use a sine ratio. Probably the trickiest part is to identify which of the ratios we need to use. But with a bit of practice, you'll get very familiar with the trig ratios. Okay, so let's now take a look at our next example. So let me draw in this triangle. So again, it looks a little bit different, not the best triangle, it looks a little bit different to the ones that we've done so far. Again, the orientation doesn't matter. We're given this side 8, we're given this or we need to find this side here, and we're given this angle in here, which is 18 degrees. So now let's take a look at what types of sides that we've been given. So this side here is opposite this angle, okay, so this makes it the opposite side, and this side is next to the angle, which makes it the adjacent side. So again, let's run through our mnemonics. So toa, so toa, opposite adjacent, so I need to use tan. So tan theta will be equal to opposite over adjacent. Okay, now tan, the angle that I'm given is 18 degrees, so I have tan 18 is equal to, let that be better, is equal to x over 5, okay, so opposite this side, which is opposite, over adjacent 5. Again, I need to multiply this across, and I have that x is equal to 5 tan 18, and if I put this into my calculator, I'll get x as 5 tan 18. I'll get x as 1.62. Again, I'll go to 2 decimal places. So again, it's very similar to the questions that we've done previously. Okay, so let's take a look at a slightly different example. So example 4. So the triangle that I'm given for this one looks something like this. My right angle is here. I have x here, and I have 2.5 here. And this time, this angle here is 22 degrees and 15 minutes. So this notation you should be somewhat familiar with, but it's essentially breaking up the degrees into smaller parts. So this part is degrees, this part's what we call the minutes, and we could have something here which we would call the seconds, but in this case we're not given any seconds. So it's kind of like decimal places but for degrees. And we'll see how we can type that in on the Casio calculators. But before we do that, let's take a look at which sides we've been given. So in this case we have opposite, and again we have adjacent. So this is my opposite side. I'll denote that with an O, and I have an A here for my adjacent side. So I need to use tan. So this is similar to the example that we just did. So tan theta, so 22 degrees and 15 minutes is equal to opposite, so 2.5 over adjacent. So this time it's slightly different to the previous examples we've done. So first of all, we have minutes now, and second of all, the examples that we've done so far have x on the top of the fraction. So this is a slightly different case where we have the unknown side on the bottom of the fraction, but it's no different. All it is that we need to apply some algebra, and we can solve it all the same. And if we do that, I can multiply the x across to the left-hand side, and I can bring the tan to the right-hand side. So I'll end up with x is equal to 2.5 over tan 22 degrees and 15 minutes. Now, let's see how we can type this in. So in my Casio calculator, I'll first press the fractions button. So that's the button that's in the second row on the far left. I'll type in 2.5, tan, then 22, then what I like to call the bubble button. So if you look on the third row, the one that's second from the left is a bubble button. So press that once for degrees, then type in 15 and press that once again for the minutes. And it will look like a small square, and both of them will look like a small square, but the calculator understands what you've typed in. Now if we press equals, we'll get x as 6.11. And so this is probably a slightly harder case of trig, but it's nothing too crazy. We'll try another one of these examples so that we're a little bit more familiar. Okay, so I have this triangle. Not the best triangle. Oh, let me retry that. Okay, that's better. I have this angle here. So this is 9 degrees. This angle here I'm given to be 63 degrees and 25 minutes. I'm given this side here, which is 45, and I need to find this missing side here, x. Okay, so first step is to identify which sides I've been given. So in this case, I have this opposite side, it's opposite angle, and I have the hypotenuse, so opposite there, hypotenuse there. Now the ratio that I will need to use is sine. So if I have sine 63 degrees and 25 minutes is equal to opposite, so 45 over hypotenuse, x. And you can see it's similar to the equation that we had before, but again, slightly different to the first three that we did. So if I use my algebra, I can find x to be 45 over sine 63 degrees and 25 minutes. Now if I put this into my calculator, again, fraction button, 45, sine 63, then the bubble button, then 25, bubble button, close bracket, and I'm given that x will then be 50.32 to 2 decimal places. Okay, so that's 5 examples so far. In the next video, we'll have a look at some more complex examples. So what I'd recommend is that you go through these examples and try it on your own, or if you have a textbook, try to get some questions from the textbook and really practice them. There's nothing too crazy here. All you have to do is get familiar with the trig ratios and a little bit of practice. So if you want, you can watch this video again so you can go through the examples. I went through it pretty quickly, but that's only because you can, pause the video, re-watch the video. So it's not a big problem if I go too quick. But if it's too fast, even for pausing, then just let me know in the comments and I'll try to slow it down. But those are the 5 examples that we had to look at. Pretty basic, a little bit harder towards the end. And in the next video, we'll have a look at some more challenging examples.